Good day, welcome to DASYLab. Today I want to analyze the outputs on various power supplies I have around the lab. I want to get the min-max value out of the signal, what that delta is. I'd also like to see the RMS value on what it is. We are using Measurement Computing's USB 1616HS data logger, and the software is DASYLab. So let's go ahead and get started here. We'll say new. First thing I'd like to do is add a nice big button to start and stop the program. So we're going to switch and set it to start stop. Bring that out, stretch it out a little bit. These are nice big start stop buttons as opposed to these little buttons up top here. Next we're going to want to get our input, go to the MCC folder, grab an analog input, double click, go to measurement, modify, and let's set our sample rate to 500,000 Hertz. Auto block size, OK, OK, and OK. To graphically see the signal that's coming in, we're going to add a YT chart. Go ahead and connect that, double click, and copy inputs. To capture the min-max, we're going to go to Statistics, Statistical Values, drop him on there, double click. On the first port, we're going to call it max, set to maximum, and we want this to be a cumulative. We're going to add another port. This one will be our minimum. Set it to minimum, and again cumulative. Go ahead and connect port 0 to 0, drag them up a hair. We'll go ahead and connect the other wire to our second port. To display that, we're going to go to Display, we're going to grab a digital meter, double click it. On the first channel we're going to call it Max. Under Options, Display Channel Name. Go ahead and set the display to 4 digits, single value. We'll add another port. This one we will call min. Make sure we're still displaying, yep. And again we want 4 digits. Okay, and let's go back in, we need to copy the inputs. To get the delta, the difference between the min-max, we're going to go to Mathematics and Arithmetic, drag them out and drop them. Want operations with 2 channels. And go ahead and connect that, double click, and we want channel minus channel. To display that, we're going to grab another digital meter. Go ahead and connect him, and we want delta. Under options, check your channel names, and let's go with 4 digits. That'll be a single value. Let's add another port to display our RMS values. Channel name, RMS. 4 digits. Only now we want to catch the RMS. Should still be displayed. Okay. Okay. Let's drag him down just a hair, and we'll connect the wire from our input down there. Let's go ahead and display our graphs and charts. Stretch them out a little bit. believe this one's our delta and RMS. And we have our min-max values. Let's go ahead and hit start. I have our data logger connected, though I do not have a power supply on it. And we're seeing a 10 millivolt swing. That's just the noise in the room. RMS is 2 milliamps. Very nice. Let's zoom in here and see what we have going on. And let's double click our vertical axis. Start at negative 0.01, end at 0.01. Say OK. And as you can see, some pretty good noise in here. Alright, let's go connect some power supplies and see what kind of information we can get. Okay, we're on the bench now. Here's some of the power supplies we'll be looking at. We have a few more that's not shown. We got some simple PWM supplies. We have an IOTA battery charger power supply. Let's take a look at a old PC power unit. We have a small DC to DC converter. If it would focus, guess not. We have a BK Precision 1786. We have the Rigol DP832. And for giggles, we'll even throw a battery pack on there and analyze that. I've found it's better to use shielded cable. We'll be connecting to the ground lug with the shielding. We got high-low on the inputs. Let's connect something up and get some numbers. Okay, we have our first test sample set up here. We got our small PWM power supply. Because the input is limited to 10 volts on the data logger, we have to run it through a voltage divider. And the Fluke meter says it is 2.215 volts. Let's see what it says in DASYLab. And here we have our first PWM. Our max is 3.5, min 7.9, delta is 11 volts. And our RMS is 3.2 as compared to our 2.21 on the Fluke. That's interesting. That's kind of a big change there. If anybody knows why, make a comment. I'll dig into it some more myself, possibly. The wave is interesting looking. I expected more of a square wave than a modified sine wave. We'll see what the other ones look like. Okay, we've tested all our power supplies. I've taken that data and dropped it into Excel and created a few charts from it. We'll zoom in a little bit here. I took the data logger and shorted the inputs. This will give us the noise that's in the system, the test system. We were just under 8 millivolts, 0076 to be exact. That is our base noise in the system. That'll be common to all our tests. The BK Precision 1786 is just under 20 millivolts ripple in the output. If you're using sensitive test equipment, that's going to throw your numbers all over the place. The Rigol, these three here, were pretty consistent and very quiet. This is a homemade power supply I built a while back, and it's right in line with the Rigol, so that's very cool. The PC power supply, I was kind of surprised as noisy as it is. We had 12 millivolts of ripple in the output voltages. I'm going to just gloss over these. If you're interested in seeing the waveforms, I'm going to tag them on at the end. And this is DASYLab. Have a great day.